Welcome to lecture 29, where we'll be finishing up now with using our last theorems in which we inserted a glide plane or mirror plane offset from a twofold axis. And in the case of P2MG, we're going to insert first a mirror plane offset from the twofold axis, and we're going to find out that that creates perpendicular to it using our first combination theorem that we talked about, a perpendicular glide plane in the other direction in the pattern. And then in the second case, instead of inserting a mirror plane, we're going to insert an offset glide plane, and that induces another glide plane. So let's begin. So as I said, the first case, let's show our P2 structure. So we'll start with the lattice. And at each lattice point, we have twofold axes. And recall that with our translation vectors in the case of P2. Now in the case of P2, we're going to have a straight line, so it's going to have to be rectangular, because otherwise, of course, a mirror plane won't work. And we're going to first use our theorem that we had. You recall that if the mirror plane, which we're operating on the a pi, is offset by some delta, we actually end up with a glide plane which is perpendicular through pi over 2 going through the a pi with a glide plane which has a 2 delta as the tau, right? So let me show you that. So let's put in our mirror plane, which has to go down the middle because, of course, we have to reflect. So that forces us, if you think about it, to have already, if we're going to have a mirror plane that just reflects these twofold axes, we're going to be offset by delta. But it really means that any 2 deltas now are going to be half of a lattice parameter, lattice edge. And so that makes sense because as we know, typically we'll reflect and translate halfway, then reflect back and translate again. So kind of the place that the mirror symmetry can go when it's offset in a pattern like this kind of dictates that the tau will be half of a translation vector. But looking at this, it says, okay, when I'm offset from this guy, I end up with a glide plane that passes through the twofold axes that I'm looking at through here. Remember, that's a theorem that we had developed in the last lecture. But of course, this is also offset by this one, by delta. So we have a glide plane here. Remember, these will be sigma 2 delta, right? And then, of course, I have one here. Now, to convince ourselves that this is all true and that that is truly P2MG. Oh, and don't forget, of course, we have a mirror plane here down the middle. Otherwise, it doesn't work because this one reflects about this, but then it also has to reflect exactly on the other thing too. There's many different ways to see that this, if I put one in here, I have to put one in here. Okay, so if I insert a mirror plane offset from the twofold axis in a P2, I end up with these glide planes here. Now we can show that with the motif our standard motif here, which you put on each lattice point. It has to be on each lattice point. And I try to minimize the symmetry here, right? By using the commas. Hopefully I did that. And so that twofold axis. Now let's look. The mirror plane I inserted means that I have to reflect this about here, which means that I have a cyan little guy like this, which is the opposite handedness, and it must mean that I have one here, right? And same thing down here. I need to have this guy like this, and this guy like that, right? So mirror planes automatically force me to have that. And if I look at, um, let's see, that's everything I think, because all I did was start with a motif there. This induces that guy. This induces that guy. This is consistent with that. This is consistent with that. Now let's look to see, do we have these glide planes that we did by this theorem? But remember, we can always tell by the motif as well to see if it's proper. So let's look at this. If I go across this glide plane, I would induce the mirror image of this guy, which would be like that, right? And then I would translate it to delta. And indeed, it lines up there. And then, of course, if I did this one too, the mirror image of that as I pop over this glide plane and then go to delta this way, indeed, I end up with that. So that proves that I have that here. Let's prove that I have this one. So here I would reflect down. Oh, sorry, I have to take this one. This one I would reflect all the way down onto this side over here, and then go ahead to delta. So that works, proving that I have this glide plane as well. So indeed, something that looks like it's toggling back and forth here, toggling back and forth here, works. And of course, these twofold axes have to work because they were there from the P2 criterion, right? So remember how it relates this guy, for example, through the twofold axis to this guy, right? This would rotate all the way around like that about this point here, etc. Okay, so that's P2MG, where we added the M first, right? So now let's do the opposite. Let's add the G and see what we get. And that will be P2GG is what we're going to get. And so the way to think about that one there is that we're going to use the second criterion, right? Which is that if I have a sigma tau, which I'm adding, right? Operating essentially on a pi point, I end up with 2 delta, where again it's 90 degrees. And again, we're offset by delta. Remember, these is an offset glide plane, so the setup condition is the same, and I'm still going to get perpendicular. The only difference is that this this glide produces another glide, and it's t over 2 below, the perpendicular line through A, essentially, right? So again, let's set this up. Here's our 4 lattice points. Let's connect them up. And through the other theorems, we know we have twofold axes and all these, and the one in the middle, right? And sticking with our color convention, we're going to add now a guy here that's going to be offset by a delta. And so what it tells us is that, okay, fine, I'm offset by delta. And then now I need to go tau over 2 below this line that is passing, through A. So if we pick this point, for example, Now remember, let's think about what, tau is, right? Well, if I set this up, like this, tau is going to be half of this direction. So if we let's say we pick this as t1 and this is t2 in a right-handed coordinate system, then when I look at this and I'm inserting a glide plane here, right? What's likely to happen is any motif I have here, I'm going to reflect here and translate down here, right? It's going to be half of this. So we expect tau to be equal to t1 over 2, right? In the original case, right? Now delta equals t2 over 4. So in the new glide plane, it's going to be tau is going to equal 2 delta, which is t2 over 2. So again, you see that in this direction, in the original, I'm going half the translation vector for my tau, and it actually induces in the other direction going half of t2 in the other direction. And remember, it's t over 2 below the line, and sorry, tau over 2 below the line, where tau is the original tau here. So in this case, tau, the original tau, is t1 over 2, and half of that is how far I'm going to be below, right? So here is tau, so half of that is right here. So I'm going to have a guy here, and of course this guy's going to produce one down here and up here as well. And so when I insert these vertical g's, right, which is this one here, I end up, in other words, this is the original sigma tau. I'm going to end up with other guys here that are induced, which would be this one. And this is sigma to delta, right? The new one. Now we can go back to our motif. To prove it. So let's put this in here. This here. This here. This here. And remember we said the first, when I insert this, it's going to take this guy. And oops, don't want to just, it's going to reflect this one and then translate down here. So the real motif then is going to be, let's see, that. Right? Again, when I insert this, it's going to take this one, reflect across here, bring it down here. It's going to take this one, reflect it across, bring it down here. And they have to be the opposite handedness of those guys up there. And then, of course, they get reflected back here, bring it down here, bring it back to the same handedness as those, which has to be the case because that's a translational data point. Now, to show you that that indeed it induces these guys over here, if we look at this guy here, I reflect about here. And it should induce something here like this, right? And then I'm supposed to go 2 delta in the new translation, which brings me here. So clearly this is a valid one. Now let's look at this one. Here, if I flip across, let's see, that actually interferes with the other one. Let me see if there's another one I can. Well, let's see this one right here. So if this one here is also valid, right, then this guy is going to be reflected about here down to here. That'd be translated to delta. And you can see that lines up with that one. And so therefore, we have P2 a GG generated from adding the glide plane to P2.